Hello, my name is Justice Chukwonyi, and in this demo, I'll be presenting ClimaTrack, which is a data-driven system that predicts climate related health risks across semi-urban communities in Nigeria. I'll walk you through the prototype, then the machine learning workflow, and then lastly, I'll be telling you about the feature selection process. So this is the prototype. When a user navigates into the application, it actually requests access to your location. If granted access, it displays your location details here, where you see your location. If, for example, you're in Lagos, in a particular place in Lagos, let's say Oshodi, it displays Oshodi here, or Ojo or Ikeja, Lekki, it displays here, and it brings the um geolocation points here, the longitude and latitude here, and then after that it gives you the prediction um calculation. For example, because this is a prototype, we have two prediction, two risk status. We have the one that says your community is safe or your neighborhood is safe, and then we have the one that says the contamination has been detected. Some contamination has been detected. Please boil water before drinking. So, but then if it is on the in real time, it's going to give you one of these, not the two of them at once. And then if it gives you this, it gives you have some quick action, which is reports issue. Like, for example, if you notice some contaminations in your environment, it's you can be able to like report the issue to in order to help others. So if you notice, we have five tabs in the application. We have this one, which is the map, and this is the heat map that actually shows you areas that the risk zones area. We have the green, which is the safe zone, the yellow or orange, which is the moderate zones, and then the high risk, which is the red zone. And then we have, and actually this risk zone, it actually auto updates every it automatically updates by itself. So this one, you see, it updated last tested 2 hours ago. Community reports safe. So it's just based on your location, it just continue updating your location and giving you feedback or notification about your location. Then the next one is the reports tab, where you can actually report an issue. Like I said before, whatever thing you observe, either a sanitation issue, a water issue, yeah, and then you put photos as evidence, and then you can use the location, either your location or maybe a location outside your location. Here you have your health tab, where you can track your symptoms daily, your health log and every other thing. And then last tab is the learn tab, which is used for like simple tips for your good health and clean water. For example, it gives you little advice or tips on what to do. If, for example, you notice some symptoms recently, it either tells you, okay, wait for a few days or do this, boil water, visit the doctor and stuffs like that. So, but then now let's go to how the model was created. This is my model. So first things first, first thing I did was the data exploration. I actually explore the data, and also I selected some certain features in order to identify the most relevant indicators. So I've then visualized the data distribution in order to like understand the climate variables. For example, how rainfall, humidity, temperature, and how they all correlate with disease incidence or health risks. So after all this has been made, in order to improve my model performance, I actually applied six key features selection method in order to select my features, like to select the best feature for the model. The first method I used was the variance threshold. This was used in order to remove features with low variance, and also the select k boost. Select k best was used for selecting the top, as the name implies, the top correlated variables. The RFE, which is the recursive feature elimination, is used to remove like less important features. The ROFE CV also for feature count through cross validation. And then I also use the mutual information. This is in order to detect non-linear dependency, just as the name implied. And then lastly, I use the chi-square test, which is used to like ensure categorical feature relevance, not using features that are not relevant to the um model. Yeah. And after all this has been made, after selecting the top features, I actually trained several models. If you look at my screen right now, you see I trained at least 12 models, which include the random forest, the gradient boost, the logistic regression, card boost, SG boost, and the rest. And after training all of them, I actually brought out my models, my best performing models by F1 score. And the first one was actually the card boost, which actually has a very impressive F1 score of 0.9457. Then the next one was the XG boost and then the gradient boosting. So this is all. And this shows after all this, I tested my model and it actually ran very well. It works very well. So um for integrating my model into my front end, what I'm going to do is that I'm going to save the trained model as a serialized file. For instance, a .pkl file using the joblib or pickle. And this model is going to be loaded by a lightweight backend API, which is built with Fast API. I use Fast API. You can use Fast or Flask, but I use Fast. Then what it's going to do is that when the application requests location access, it gets the location details. It sends the location details back to the backend, back to the backend endpoint as a JSON request. And after sending it, the backend is going to call the model and then it's going to return the predicted risk score. And the front end is then going to display it dynamically here, and it's going to display updating the risk indicators and visualization charts in real time. So this is my project. Thank you.